Today we are going to discuss the texture classification of igneous rocks. Now the various, you can say, the textural terms that are used. First, the pheneritic. Once we say pheneritic, means the rock is made up of crystals which are visible with naked eye, means without aid of microscope. And you all know that all pure plutonic or intrusive igneous rocks, they have pheneritic texture. So all plutonic rocks, they are phanerites in general, or they have the pheneritic texture. Similarly, the term aphanitic is used when the crystals are too small to be visualized with naked eye. Means we cannot see them with our natural, or you can say with eye without aid of, you can say, microscope. So all your volcanic rocks or extrusive rocks, they have the aphanitic texture. For example, your rock rhyolite, trachyte, basalt. These are the names of your volcanic or extrusive rocks. They have the aphanitic texture. Then the third is the porphyritic. Porphyritic means the rock is composed of two different dominant grain size. The large ones, they are called the phenocryst, and the smaller in which they are embedded, they are called the ground mass. Now depending upon whether if you can identify them in hand specimen, they will be called as megaporphyritic. But suppose the difference in sizes is too small, that cannot be seen with naked eye, but can be seen under microscope, that will be called as microporphyritic. So this porphyritic again can be divided into megaporphyritic and microporphyritic, depending upon they are visible with naked eye or cannot. Then next is the fragmental, means composed of disaggregated your igneous grains, composed of these your all pyroclastic rocks. They have the fragmental texture, means these your tuff, breccias, they are fragmental texture, means these different class they are embedded in the ash or material, that is called fragmental. Similarly, the term pegmatite is used for very large, that is means pegmatite, you all know, is a museum of minerals, and the pegmatite, they crystallize the end stages of magma, and the grain size is very large. Once we say the grain size, you can say the ratio of human beings in size is 1:4, means smallest, you can say the miniature human being can be of 2 feet or 3 feet, and you can say the highest can be of 7 to 8 feet. So ratio is 1:4. But in case of your igneous rocks, this ratio is more than 1:1000. Means in pegmatites, the grains are so large that we cannot take in our arms. So they are extremely grain size within and these forms veins or layers within the plutonic rocks. Then next is your glassy, means non-crystalline, means the igneous rocks, they are solid, but they are non-crystalline, they are amorphous, they are glassy, right? This obsidian, right? Rocks like this is very common. These volcanic rocks is glassy, or you can say a zero grain size. Similarly, the term vesicular, vesicles means the holes, vesicles, pores, cavities that are formed because the hot gases, they escape to the atmosphere. In volcanic rocks, when they crystallize on the surface, during cooling, the gases, they escape to the atmosphere, and the cavities, pores, holes, they are formed in that rock. They are called the vesicular. Very common in the vesicular basalts. So this term is there. Now the compositional term for, you can say, for igneous rocks, once we say felsic, right? Felsic means feldspar silica, as the name means that rock is feldspar silica dominated, means it is having your less mafic minerals. In different classifications, we have this different, but here you try to understand that felsic, feldspar plus silica means when silica content as such, means on the chemical composition that is carried out, that silica comes to be in or ranges between 55 to 70%. Somewhere it is even given more than 66%. That is different. But overall, what is the character of these rocks? Because they have less iron, magnesium, so they are light colored silicate minerals. They have generally your quartz, K feldspar, and your plagioclase feldspars. Then the intermediate rocks, that is between felsic and mafic. Silica is from 55 to, you can say, 65. Once we say in some books it is from 52 to your 66 also, doesn't matter, but very near it to that. Means these rocks have Na rich plagioclase dominates, right? And then mafic, once we say the term is magnesium and iron rich rocks, right? The silica content is from 45 to 50%. In some it is 45 to 52% in matter. And once we use the term ultramafic, means your mafic minerals, they are more than 90%. And now once they have mafic minerals more than 90%, naturally the silica content is less, and that comes out to be less than 45%. So they are in that silica sense they are ultra basic. Right? For example, your rock nepheline cyanide is in ultra basic because the silica content is less than 45%, but it is not ultra mafic because it doesn't have any mafic mineral. So you can say all ultra mafic rocks are ultra basic, but all ultra basic are not ultra mafic. If you take the example of nepheline cyanide, you will understand it very easily. Once we say ultra mafic, if the term ultra mafic is applied, it means that rock has more than 90% mafic minerals. Once a rock has more than 90% mafic minerals, means iron, magnesium rich, naturally the silica content will be less than 45%. So on that silica basis, that rock is also ultra basic. But if you take vice versa, rocks which are ultra basic, for example, your rock nepheline cyanide is ultra basic, having silica content less than 45% because your feldspathoids are there, nepheline. But it doesn't have any mafic mineral. So that is not ultra mafic. So remember saying that all ultra mafic rocks are ultra basic, but all ultra basic are not ultra mafic. Now then the classification, if you go for that, of common igneous rocks, once we say felsic, you divide in two categories, pheneritic and aphanitic. Pheneritic, you all know that those which grain size can be seen with the naked eye. So your rock granite, cyanide, monzonite, right? This is in case of, so once we say rock phanerite and felsic together, means these three examples will be there. Once we say aphanitic felsic, means rhyolite, trachyte, latite, these will be there. Because once we say phanerites, you can see in this column granite, cyanide, monzonite, granodiorite, diorite, gabbro, like the pyroclastic. They are all phanerites. But further if you divide phanerite, felsic, phanerite intermediate, phanerite mafic, and phanerite ultramafic. So phanerite ultramafic, you can see from the chart, it is the peridotite. Similarly from the chart, if you see aphanitic intermediate, that is dacite and andesite, that is there. Right, then moving to this, you can have this classification of your, on the basis of your this, of your QAP diagram which is there. This is separate for your phaneritic rocks, or you can say the plutonic rocks. The different textual term we already had discussed when the classification of igneous rocks we have taken it, and the different field of different rock types are plotted. Now in case of your mafic rocks, or you can say ultramafic. So now these ultramafic rocks, there are various triangular diagrams we can use. On one hand we can have the plagioclase, one pyroxene, then the olivine, right? And then different fields of different rocks that can be marked in these diagrams, right? Then silica aphanitic igneous rocks. Aphanitic means this is for the volcanic rocks, same QAPF diagrams. The better for this your volcanic igneous rocks, your TAS diagram. This is on, because in volcanic rocks it is difficult to identify the grain size and to identify the say not grain size but actual minerals, right? So it is tough to classify on the basis of their mineralogical study. So for that for volcanic rocks, the classification better used is on the basis of the chemical composition, and in that on this your x-axis it is your SiO2 content that is taken, and the y-axis it is weight percent Na2K2 is taken, and the different fields or different root names of different your volcanic rocks, you can see it here, right? So this is better. This is TAS, total alkali silica diagram, that is used for this, right? And similarly for your pyroclastic rocks, pyroclastic we use the term fragmental. So taking on one end glass and rock fragment the crystals. Now you know if the rock is majority, this is the, you can say glass, that will be vitric tuff. So if it is rock fragments, that will be your lithic tuff. If the crystals, then the crystal tuff. Right. Similarly, depending upon the sizes, ash, lapilli, and the blocks and bombs, means sizes of the fragments that are there, the different terms are there. So if the grain size of those fragments is less than 2 millimeter, that will be tuff. Like blocks, if they are more than 64 millimeter, right, then the term blocks and bombs are used, and that are your pyroclastic breccia or agglomerate that is used. Similarly, when this size is from 2 to 64, that is lapilli stone is used. And in between you can see the different names, lapilli tuff, breccia, like this. So this is what you have to, because in nature things are not perfect what you study in the books. There is gradual variation, means from one side it will be vitric, then coming to that it is breccia, the agglomeratic, like this. So this is the gradual. If you in a field, if you take it traverses, right, it is not that the total, because once there is a, say suppose there is a granite intrusion, there will be rapid cooling on the margins, central part will be cooled slower. And if you take section of this, right, so there will be difference in, because the cooling conditions and the crystallizing conditions. So they are different. You can say you rock types or different minerals or the sizes grains will be formed, you will find in the field. Now similarly, this is what a polysynthetic deformation or the twins. Polysynthetic, that is common in the calcic feldspars, right, and orthites in that. This is the calcic feldspars. This is, we can say, this is very common. This is myrmekite, formed as plagioclase bond cells. Myrmekite means it is the intergrowth of quartz and the your plagioclase feldspars, right? You are twinning, polysynthetic twinning. So what is there that important means you can classify rocks on, because today we just took the idea of the textures. If you're taking the different textures, we can even have great detail of classifying the rocks on this basis of the textures also, right? So this is an idea to just give an idea that how can the depth, or you can say detail, even on the classification of igneous rocks can be done on the texture. So thank you very much. See you in the next class.